Walaikum Assalam. Walaikum Assalam. In the previous class, we were discussing about pH, right? And how to calculate H plus ion concentration when you are having different cases, right? Let me remind you that I am completing whole theoretical part, right? Since I am waiting that there may be eagerly beginning of physical classes, offline classes. So I am completing the whole theoretical part of this chapter, and when we have offline classes, we can enjoy the numerical problems of this discussion. So let me complete the theoretical part. We have taken what is the meaning of electrolyte and non-electrolyte. Then we have discussed about strong and weak electrolyte. We have discussed about Arrhenius, Lewis, and Bronsted theory of acids and bases. Then we have gone for self-ionization constant, ionic product of water. Then we went for H plus ion, and then for pH. And all the possible cases in terms of pH we have discussed. Now come to the other discussion. That discussion is something like this. Again, I am repeating that word. I am completing the whole theoretical part first. And once we have all that, we will collect all the equations at one place, and then we'll go for discussion with respect to numerical approach. Come on. Now, today, we have a beautiful discussion to enjoy in ionic equilibrium discussion, and this has a number of possible questions, theoretical, conceptual, and as well as numerical. Let us see how to proceed for that one. Suppose, for example, if I am saying that I am having a solution in a container. Say, for example, we are having a solution, and this solution is found to have pH value is equal to, say, for example, 4. Right? Assalamu alaikum, Sayyid Yusuf. And removed. की इंतहा लानत है. चलिए अहमद साहब कौन क्यों खामखा के आते जब आपको पढ़ना नहीं है कहीं तो पुस्तक नौकरी कर लेना क्लास में क्यों आ रहे हैं आपको क्लास का नाम लिखने नहीं आता, आपको रोल नंबर लिखने नहीं आता, तो आप क्लास में आने के काबिल नहीं है। और मेरी क्लास में कई पढ़ा लाइफ को एंजॉय करो बेटा, घूमो फिरो, हैदराबाद की रोडों का नाप लो, लेंथ कितना है, ब्रेड्थ कितना है, वो आपके लिए काफी है। Suppose, for example, you are having pH is equal to 4, then what we can say, yes, sir, this is an acidic solution. Fine, I got it. Now what happens, rule number 1 added a small amount of strong acid in it. What will happen? Addition of small amount of strong acid will have a release of H plus ion. Therefore, since you are saying it is an acidic solution, already we are having very high H plus ion concentration. Again, you are adding strong acid. The strong acid releases H plus ion. Therefore, the concentration of a free H plus ion increases. Take care of my language here in this case. I am saying concentration of free H plus ion. This is the point which I want to enjoy in the next discussion. Free H plus ions increases. Therefore, pH value of solution decreases. It's quite obvious. A simple statement, sir. If you add acid, pH value of solution decreases. Now, rule number 2, he has added a small amount of strong base. Okay, once you're having addition of strong base, what is the problem of strong base? That phase will simply release OH minus ion. And suppose, for example, if those OH minus ions are freely available, already here also we have some OH minus ions, right? Once you're having OH minus ion, then concentration of OH minus ion increases. No, sir, I want to enjoy discussion with respect to concentration of H plus ion. It is now less. Therefore, concentration of free H plus ions, here also like same thing. It is supposed to be decreasing, therefore pH value increases. This means to say, I am having a solution of, say, for example, pH 4 acidic solution, in which I am adding small amount of strong acid or small amount of strong base. Upon addition of these two substances separately, I am observing that there is a change in the pH value. Nice. Now what I have done, I have changed that situation, and in place of a solution whose pH is equal to 4, I have taken another solution, and that solution is pure water. Say, for example, either you are having pure water, or suppose, for example, you are having sodium chloride solution, aqueous solution. What will be the pH? Definitely pH is equal to 7, because pure water is neutral and sodium chloride is of course neutral system because it is salt of strong acid and strong base. Therefore, here we are having pH is equal to 7. Now, what happens? Rule number 1 came. He added small amount of strong acid. What happens? Nothing will happen, sir. Sodium chloride solution has certain H plus ions. Neutral solution will also have H plus ion. Basic solution will also have H plus ion. Right? Pure water also has H plus and OH minus ion. Therefore, when you are adding strong acid, the effective H plus ion concentration will be more. I should say that free H plus ions will be more in the solution. And once you are having free H plus ions more, increase in free H plus ions, pH value decreases. Similarly, if suppose, for example, you are adding small amount of strong base, because of OH minus ion, again what happens? H plus ion concentration decreases and pH value increases. Fine. This means to say, we have taken 3 examples. One solution whose pH is less than equal to 4. One solution, water, pure water, pH is equal to 7. And aqueous solution of sodium chloride, there also we have pH is equal to 7. And in these solutions, whenever we are adding small amount of strong acid and small amount of strong base, what is happening? Free H plus ion concentration is increasing. Free H plus ion concentration is increasing, or you can say free OH minus ion concentration is increasing. Because of that, pH value is changing. Decrease or increase of pH value. I am interested to enjoy the term change in pH value takes place, right? Once you understand this idea of 3 different solutions, now let us come to my aim. What I want to discuss here in this case is, suppose, for example, I am having a solution I have taken a new solution now, which is named as some XYZ say solution, for example, AB solution, something, right? I don't know what is the name of the substance. There's an unknown solution given to me. Okay, aqueous solution of something AB, and they have declared that, sir, pH is equal to 4. So only I know one thing, that this solution is acidic in nature. That's all, right? I don't know the name of the solution. Now, what happens? Suppose, for example, in this solution, roll number one came again, right? A small amount of strong acid is added. I am somewhat lazy, therefore I'm not writing that word small. Keep it that one, because that word is important for me in future discussion. I am adding small amount of strong acid. Naturally, what I am expecting? I'm expecting that already we are having some H plus ion concentration. Because of addition of strong acid, H plus ion concentration increase, pH should decrease. It remember that after adding that, when I check that, pH remains almost same. pH remains constant, IP books says, and some lecturer says, but it is not scientifically correct. We'll prove why it is not correct. pH remains almost the same for 3.9, it says something like that, right? Okay, then what you are thinking, sir? Something is wrong with instrument which is measuring pH. So you have changed the instrument and you have taken new instrument and checked again, sir, pH remains almost same. Okay, no problem. Let us go ahead. Roll number two came. He added small amount of strong base. He observed, or he is expecting that pH value should increase, but pH again remains almost same. Then roll number three came and he diluted the solution. Upon dilution, there is an increase in quantity, there must be change in molarity and pH must change. No, sir, pH is almost constant. And suppose, for example, if this solution AB is kept for long duration, 2 minutes, then again it is observed that it is found to be constant. What is the meaning of that keeping long duration? It means to say you are allowing the solution to interact with atmosphere. Atmosphere has carbon dioxide. That carbon dioxide may dissolve and there is a formation of carbonic acid, which may change the pH value, but bad luck, there is no change in pH of the solution. Then you are now trying to start, sir, what is the problem? Why the previous two solutions are supposed to have change in their pH value? Why this solution is not having change in pH value upon all these aspects, right? Remember that. Why it is going on, we'll discuss later on. First of all, try to understand who is this fellow. Remember that this fellow is called a buffer solution. A solution whose pH is remaining almost same even upon addition of small amount of strong acid, small amount of strong base, upon dilution or upon keeping for long standing. If suppose, for example, pH is not changing, that type of solution is known as a buffer solution. Take down this, I'll discuss you later on. Take down this much. నేను కొంచెం క్లాస్ చేసుకుంటాను. ఈ పిల్లలు అక్కడ ఉన్నారు అందరూ. శ్రీకాంత్ సార్ వస్తే తీసుకోండి, చేసుకోండి. కొంచెం మనం కంటిన్యూ చేసేసి ఏంటిదని రిపోర్టింగ్ సబ్జెక్ట్ గురించి చెప్పండి. ఓకే ఫైన్. Now the question comes here in this case that if suppose the solution is not changing its pH value, even you are adding strong acid and strong base, then what is the problem? What is the problem, right? What I have to say here in this case, first of all, a solution which maintains its pH almost the same, or one more way of saying is a solution which resists the change in its pH value. It should resist. It will say, no, I don't want to change my pH. Resists change in its pH value. Okay. No, sir, there is one more definition. IIT students, enjoy this one. A solution which possesses reverse acidity or reverse alkalinity upon addition of small amount of strong acid or strong base, or upon dilution, or upon long standing, is called a buffer. Yes, it is called a buffer solution. This is the way with which we can say that we are having a solution is said to be buffer solution if it is maintaining its pH almost same, or it is resisting the change in its pH value, or it possesses reverse acidity. What is the meaning of that? If you add acid, you are thinking that pH from 4 becomes 3 to 1. No, it will come back to 4. You are adding base. What you are expecting? It goes to 5, 6, 7. No, it will come back. Reverse alkalinity, reverse basicity, reverse acidity. If you are having this type of property in any solution, that solution is called as a buffer solution. Take down that. Kept for okay. Wait a minute, I'll correct it. Now is it comfortable to you? Long duration. If you are leaving it in the atmosphere, then even then there will be no change in pH value. Go ahead, go ahead. Is it over? Fine. Now, as a student, you will having a problem. No, sir. What is the problem? Why this solution is not changing its pH? Why it is remaining constant? Right? It is quite obvious as we are having our life process that also number of times management is saying write down your class section number and then write down your roll number. But there are certain students, for example, Sayyid Yusuf, 6 times I have removed, 6 days I have removed, and today also he came without any roll number. And then no problem, sir. They are called buffer students. A solution which does not change its pH value upon addition of small amount of strong acid or small amount of strong base will try to maintain its pH almost constant is called buffer solution. Nice, we understand it. Once you understand this, naturally, as a student, you will say, sir, who is this fellow? Who is this fellow? Number one. Number two, why is this fellow is like that? Why he is behaving in this manner that he is not changing its pH value? Come on, let us try to enjoy the game in such a way that who is this fellow? Remember, in general, buffers are of two types. Buffer solutions are of two types. One is called simple buffer. One is called mixed buffer. Okay. Simple buffer. What is simple buffer? Simple buffer is a salt. IIT students, scientists take care of that. A salt of weak acid and weak base. Any salt of weak acid and weak base is called as simple buffer. For example, let us take number of examples are there. HCOO NH4 ammonium formate. Ammonium hydroxide, weak base. Formic acid, weak acid. No, no, sir, our close friend is acetic acid. Okay, we love this fellow number of times we use this. Ammonium acetate, right? Zinc hydroxide is that one, and then HCN, hydrogen cyanide. Say, for example, zinc sulfide H2S, weak acid. Zinc hydroxide, weak base. Copper cyanide, copper hydroxide, weak base, and hydrogen cyanide, weak acid. So many examples are there. It is now your job to understand and try to recall number of. You don't memorize it. You are not a parrot. You are a scientist or a doctor. Just concept: weak acid, weak base. You have to take that one, right? So now, once we are having this, then we say, sir, who is this fellow? Mixed buffer. Mixed buffer is of two types. One is called acidic buffer. The other one is called basic buffer. What is acidic buffer? Acidic buffer is mixture of Therefore, mixed buffer, mixture of weak acid and its salt with strong base. Come on, let us try to enjoy the examples. Weak acid, any weak acid you can write. For example, your favorite example just now you said acetic acid, weak acid, and it's a salt with strong base. Who is that fellow? First group metal hydroxide, second group metal hydroxide. Therefore, CH3COONA. Acetic acid and sodium acetate mixture is called buffer, mixed buffer, mixed buffer. Weak acid and its salt with strong base. No, sir. Formic acid is weak acid. It's salt with strong base. Potassium hydroxide is a weak, strong base. Potassium formate. This is a buffer. This is supposed to be buffer. Next. We can take number of examples, sir. Oxalic acid, COOH, COOH plus COONA, sodium hydroxide, COONA, sodium oxalate and oxalic acid, right? So many examples are there. Phosphoric acid, weak acid, calcium phosphate, Ca3PO4 taken twice. Okay, next. Suppose you are saying, sir, oxalic acid is taken. Why don't you take aromatic acid? Come on, let us enjoy Krishna Mohan sir class. And then say, sir, benzoic acid. And it's a salt with strong base, sodium hydroxide, potassium hydroxide, calcium hydroxide, something like that, right? Potassium benzoate. No, sir. Krishna Mohan sir also says that phenol is acidic in nature. Okay, it's the acid, therefore sodium phenoxide, potassium phenoxide. Okay, like that, right? Potassium phenoxide along with phenol is an example, right? H3BO3, boric acid, carom board, right? Na2B4O7, sodium tetraborate. It's a salt with strong acid, strong base, right? Like this, we have so many examples. As much you are doing practice in this example, so much you can enjoy the buffer solutions, right? Next. The next one is supposed to be something like this. Naturally, it must be called as which buffer? Basic buffer. Let us have some cheating process. What is that? Acidic buffer, mixture of weak acid and its salt with strong base. No. It is to be written as mixture of weak base and its salt with dash strong acid. Come on. What are weak bases? D block element metal hydroxides are weak bases. Ammonium hydroxide is a weak base. Okay, let us enjoy first with well-known example, ammonium hydroxide along with HCl, ammonium chloride, ammonium hydroxide along with sulfuric acid, ammonium sulfate, ammonium hydroxide along with nitric acid, ammonium nitrate. So many examples you can frame with this fellow. Okay. Similarly, zinc hydroxide along with sulfuric acid, copper hydroxide along with nitric acid. They are all examples of mixture of weak base and its salt with strong acid. Okay, nice. I got it, sir. What is buffer? I understood. Who is buffer? I got it. Now, my main question is, sir, why this fellow is like this? Why it is not changing its pH value? Take down this, then we'll proceed. Is it over? Go ahead, go ahead. Fine. Once you complete this, then our main discussion is, sir, why this solution is not changing its pH value. To answer that and to understand, go back to the first slide and what we have said there, why there is a change in pH value of water, why there is a change in pH value of sodium chloride solution, right? I have given some answer in case of discussion. That the answer was when you are adding small amount of strong acid, H plus ions are released. Whenever you are adding small amount of strong base, OH minus ions are released. Remember, if those released H plus ions from the added strong acid, if those released OH minus ions from added strong base are freely available in the container, pH changes. I'm repeating my sentence. Whenever you are adding small amount of strong acid, H plus ions are released. If suppose they are dancing in the container free H plus ions, like free H plus ion, when you are adding small amount of strong base, OH minus ions are released. If those OH minus ions which are being released by strong base, added strong base, if they are dancing in the container freely, suddenly pH value changes. Okay. It means to say in buffer solution, there is no change in pH value. It means those released H plus ions from the added strong acid, those released OH minus ion from the added strong base may not be free. They may not be free. What is the meaning of may not be free? They might have been used by some fellows. Instead of using the word used, I said they will be captured. They will be captured by some component and they are not allowed to be free. Therefore, pH remains constant. Yes, buffer solution has a typical property. There are two properties because of which a solution is said to be buffer solution. Number one, it will capture the released H plus ions from the added strong acid and it will not allow those fellows to become free and there is no change in pH. And it will capture the OH minus ion released from the added strong base and it is not allowed to dance freely in the container, hence pH remains almost the same, right? And after that, this is not the complete property. After that, after capturing, there is a formation of weak electrolyte. If suppose after capturing, there is a formation of weak electrolyte, pH remains almost same. That means a buffer solution has two properties. Number one, it will capture released H plus ions from the added strong acid. It will capture released OH minus ion from the added strong base and results a weak electrolyte. This is called buffer action. It is known as buffer action. In buffer action, come on, let us see how to go for that. The next topic is why and how. Answer is buffer action. What is buffer action? Buffer action means it is the property of buffer solution by virtue of which it captures released H plus or OH minus from added strong acid or strong base, resulting in weak electrolyte. Hence, pH remains almost same. Here, remember two properties. Number one, what is that? Capture. Number two, resulting a weak electrolyte. These are the properties which we call as buffer action. Because of this behavior, because of this approach, remember that buffer will maintain its pH constant. सर समझ में नहीं आया, बिल्कुल नहीं आएगा, थोड़ा थोड़ा समझ में आएगा, राइट? कुछ को समझ में आया होगा, एग्जाम्पल लेंगे तब समझ में आएगा. चलिए एग्जाम्पल कंसिडर an acidic buffer. Who is that fellow? CH3 COOH plus CH3 COONA, weak acid, and it's a salt with strong base. Okay. Now, if suppose, for example, you have taken buffer solution, naturally you have taken aqueous solution. Now the question comes, sir, who are dancing in the container? Acetate ion is dancing along with H plus ion. Sodium ion is also dancing, right? And there is one more thing which you have to remember. Unionized acetic acid is also dancing in the container, and this solution is supposed to be acidic buffer because of this H plus ion. We are not going to disturb this H plus ion because due to presence of these H plus ions, it is called acidic buffer. Nice. Now what happens? Nothing will happen, sir. Come on, start the process. What is the process? Rule number 1 came and he said, sir, I want to add strong acid. Come on, if strong acid, small amount is added, what happens? H plus ions are released. Now the question is, if these H plus ions are allowed to enjoy freely in the atmosphere of the solution, pH will certainly change. But buffer solution say, no, I will not permit you to dance freely. I will capture you. Who is going to capture H plus ion? We have acetate ion, we have Na plus ion, we have acetic acid molecule. Therefore, what happens? This acetate ion say, come on, welcome H plus. I don't want to dance freely in my container. Therefore, you are disturbing the atmosphere of the system, right? You are changing the pH of the system. Come on, come and get associated with me. This is called capturing property. This H plus ion is captured. And there is a formation of weak electrolyte, CH3COOH. Scientists, listen carefully, listen carefully. We have formation of weak electrolyte. What is the meaning of weak electrolyte? It is weak acid. And who is this fellow? Conjugate base of weak acid in a strong. It means like this. Therefore, I am saying that there is a possibility of reverse reaction, right? 100 H plus ions are accepted, but 10 H plus ions are given back. When 10 H plus ions are coming back, how can you say pH remains constant? Yes, this is the logic in science, that we should not say pH remains constant. Of course, no problem. Intermediate book says pH remains constant. No, it is remaining almost constant. That word almost has a beauty, that rate of forward reaction is more than rate of backward reaction, right? So what is the buffer action? Buffer action is this one, capturing H plus ion. This is capturing H plus ion. And after capturing, there is a formation of weak electrolyte. Remember, this is important. Only capturing is not suitable, right? There are certain people who are doing crime in the society, and there is a sub-inspector appointed in the society, in the colony. He is capturing all the criminals and locking it up so that peace remains constant, right? But in the evening, he is going and he's saying from the back door, come on, give me some amount and go out. Go out. If it is releasing the H plus ion back, then what happens? The piece is again variable. But who is that other fellow? He is capturing and he is not allowing to go out. Weak electrolyte is formed, not allowing to go out. Therefore, buffer action is combination of two terms. One is we have to capture the H plus ions released from the added strong acid, and then we have to result in weak electrolyte. Therefore, this implies pH remains almost the same. No, sir, I am adding base. Go ahead. If strong base, a small amount of strong base is added, OH minus ions are released. Fine. Now, once these OH minus ions are freely available in the container, there will be certainly change in pH value. But what buffer solution say, no, I am going to capture this. Who is going to capture that OH minus ion? Remember, you should not answer. I think some of you may be answering, sir, H plus ion, sir, Na plus ion. No, H plus ion should not be disturbed because of this H plus ion, that fellow is called acidic in nature. You are disturbing the whole story. Therefore, you should not touch H plus. Why you are saying H plus? Plus minus, job is finished, right? You should not talk about it. No, sir, Na plus. Okay, go ahead. Na plus. Na plus captures the OH minus ion. What is formed? Sodium hydroxide. Who is that fellow? Strong electrolyte. And then he will act like that sub-inspector who is in the morning light, who is capturing all the criminals, and in the night moon light, he is going and from the back door, he is saying, come on, give me 25,000 and I enjoy your life. There is a formation of strong electrolyte. Therefore, remember that this is not correct. We should not have formation of strong electrolyte. That means whenever you are having buffer solution, it should capture the released OH minus ion, and there must be formation of weak electrolyte. Who is going to capture? Acetic acid. Acetic acid will capture. There is a formation of CH3 and water. Who is that fellow? weak electrolyte, therefore backward reaction. This implies pH remains almost same. This is called buffer action. Similarly, at home when you are doing study hour, consider a basic buffer. Go ahead one by one, same type of steps and see how and who is going to capture the substances. Take note that, and that is the end of what we can say buffer discussion today. Remaining part we'll discuss on Monday. In our Sunday examination, we'll having ionic equilibrium, all conceptual questions till buffer solutions. Till buffer solutions, all no numerical question because I have not done problems. Only theoretical conceptual questions on ionic equilibrium. Go ahead. Any doubt to ask? Done. Thank you. Remaining we'll discuss on Monday.